Alright, welcome back to lesson 2-5. Welcome back. Hopefully you watched lesson 2-3, 2-4, and if you didn't quite get it, go back rewatch it, right? It'd be better to rewatch it and maybe get it and take a little bit longer than sit there and be like, oh, I don't know what to do. Alright, so today we're talking about sketching graphs and comparing functions. So first thing we're going to do is try to fill out this. We're going to try to fill out this. You can sketch the graph of function using the key features, knowing the domain, range, intercept, symmetry, end behavior, and extrema. We should know what all these mean. Remember, domain is all of the x values. Domain is x. Range is y. Intercepts are where it crosses the x-axis, the y-axis. Symmetry is where you can cut it in half, and it's the exact same on both sides. End behavior is these arrows right here. End behavior are those arrows right there. And then extrema is what we're talking about right now in this picture. All right, extrema is the highest and lowest points in a certain finite area, in a little area. All right, so label the graph to identify its key features. So starting here, what's going on from this arrow up to this point right here? Hopefully, if we look left to right, it's going up, so therefore it is increasing. So we'd write increasing in that box, but as you know, if you've watched these other videos, my handwriting is awful. So you also see me in class every day, so yes. All right, now what about, I'll try to color code it so hopefully it makes a little bit more sense. And now from this point to this point is this box. So if you're at the top of a roller coaster and you're going down, it'd be a decreasing part of the function. So decreasing part of the function. All right. We'll go yellow. We'll go red. All right. Now from the bottom to the top, what's happening? Hopefully you see it. Increasing. The graph is increasing. Increasing. Perfect. Okay. So we have increasing, decreasing, increasing. Okay. Now we have this little point up here. That little point up here. If we made that little box like I just did, this would be a relative maximum. Relative maximum. Relative maximum. In this little finite box that I created, it's the highest possible point. Therefore, it's a relative maximum. Right, relative maximum. We'll go with this. Now, if we look at this point down here, if we box that and make that a little finite section, this would be a relative. Since it's the lowest point now, it'd be minimum. The minimum, lowest point in this little finite area would be a minimum, relative minimum. All right. Hopefully that's okay. If you need to pause it, so you can copy it all down. All right, let's go to example 1. Cycling 2015. Christoph Strasser set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over the 24 hours can be represented by a function. Sketch a graph that shows the distance traveled y as a function of time x. So before sketching, consider any possible constraints of the situation. It is not possible for Christopher to ride for a negative amount of time or ride negative miles. It's not possible. You can't go back in time. And negative miles doesn't make any sense because it's all forward. Just like you in your cars, there's an odometer. That's what it's called. It keeps track of how many miles you've driven in the car. It never can go backwards. It can only go forwards. Right? So therefore, the domain and range are restricted to non-negative x and y values, and the graph exists only in the first quadrant. So y-intercept, no distance traveled when he is ridden for 0 hours. So, let's change the color, make it a little darker. We'll go purple, like purple. So it's going to be right there at the origin, because he hadn't had any miles. He hasn't ridden any miles when he started. So that's why it's starting at the origin. Linear or nonlinear, the graph of the function is linear. What that means is it's going to be a straight line. So linear functions are straight lines. Okay. positive for time greater than 0. For time greater than 0. Increasing for time greater than 0, because he can only increase the total distance he has traveled. All right, the graph is a straight line that is positive and increasing for all hours ridden. And behavior, as the number of hours he has ridden increases, the number of miles he has traveled increases. That makes sense, because they're both just going up and up forever. All right, so we can go. Now it says, if you look back up here, that in 24 hours he rode 556 miles. So at 24, he ran 556. So that's roughly right around this point right here. So this is going to be real bad. Do your best to draw a straight line. Not as bad as I thought it was actually going to be. Not bad, not too bad. So that's what it was going to be. The reason how I knew that was going to be there was because it says after 24 hours, in 24 hours, he rode 556 miles. 556 miles in 24 hours. So if we go down here to the graph, time, we went to the right 24, and at that point he had ridden 556 miles, so it's roughly right there. And since it's a straight line, you just connect the dots from the origin to that point. All right. Okay. On to the next problem. A person's happiness can be affected by temperature. Sketch a nonlinear graph that shows the happiness of a person Y as a function of temperature X. Interpret the key features. So it's positive between 25 Fahrenheit and 89 Fahrenheit. That means it's going to be above the x-axis. All right. You know what I'm going to do here? I'm going to go 2 pages so that we can kind of see both. We can kind of see both. I know it might be a little difficult. It's a little zoomed out over here, but just so I can kind of get some of the important information. All right. So here we go. The first thing we're going to want to do is look at the symmetry. Symmetry is what we want to look at first. A person's happiness for temperature less than 57 degrees Fahrenheit is the same as happiness for temperatures greater than 57 degrees. So what that's telling us is that at 57 degrees, that's where the point's going to be the highest, and that's where it's going to be the highest, and that's where it's going to break from this way to this way. So it's going to break into 2. So it's positive between 25. So at 25, I will say it's right there. It's in between 25 and this line right here. And then 89, we can say, is right before this line right here. Okay. So how did I know that 25 and 89 were going to be my x-intercepts? How I knew that was because anytime it talks about positive and negative, that's where our x-intercepts are, those numbers. So 25 and 89 are our x-intercepts. X-int, 25 and 89. So that's why we put these little dots here. I know it's hard to see. My apologies. My apologies. Okay. So, negative for temperatures less than 25 degrees and greater than 89. So, it says it's increasing for temperatures less than 57. So, when we go to 57, that's roughly here. It's going to be increasing. So, when it's less than 57. So, from here to 57, so what we want to do is draw our little line, our symmetrical line. Okay. Now, that means it has to be symmetrical on the left side and the right side from this. All right. So the reason I got that was because increasing for temperature less than 57. Right, so it's got to be from this side to here, it's got to be increasing left to right. And from here to here, it's got to be decreasing. So relative maximum, that means it's going to be the highest point. So at 57, when a person's happiness is about 85. So that's going to be right around this area. I'm just kind of colored it as best I can. Oh, a little too much. Okay. I might change the color too, just to kind of make it pop a little bit. Okay, so it's somewhere in that range because it says right here relative maximum, so that's our highest point. It's going to be about 85, the happiness, and happiness is our Y, so it goes up to 85. And it gives us this point right here, 57, 85. So we get 57, 85 is up here. All right, so now we can connect a few of our dots. Let's go, we'll go green. We'll go this lime green, really make it pop. So what we want to do is draw our graph from here up to here. And then we'll draw our graph from here to here. It's not perfect, I know, my apologies. I'm trying my best. Your graph is hopefully much more symmetrical than mine. Okay. And then the end behavior talks about basically going down forever. As temperature increases or decreases, a person's happiness decreases. So all that's saying is that this will just go down forever, down forever. According to this, you know, we're all happy gamers, all right? So that would be our graph. That's how we're going to graph it. So again, how we get our x-intercepts is looking at the positive and negative. The numbers right there are our x-intercepts. Increasing and decreasing tell us our symmetrical point, if there is one. That's why I'd like to look at the symmetry point, just to see if there is one. All right. And then relative maximum tells us our highest point, or potentially lowest point. In this case, it was a maximum, so our highest point in relative area. All right. So now I'm going to go back to one page. And we can work on the check now. All right. So Mariana used the key features to sketch the graph of x as a function of y. Determine the key features in graph to identify which key features Mariana graphed correctly and incorrectly. Whew. So positive, between x equals -3. So -3 is right here. And 0 is right here. And for x has to be greater than 2. So I would say from here, from -3 to 0, it's positive. -3 to 0, it's positive. And when 2 is greater, so as x moves to the right of 2, it's going up, so it's positive. So I would say that is correct. That is correct. Now let's look at negative. Make that red. Negative. So when x is less than -3, so when it's left of -3, it's negative. I would say that is correct. I would say that is correct. So that one's good so far. And between 0 and 2, it's negative. I would agree from here to here, going underneath. So yes, that's another correct. So far, she's doing very well. So far, she's doing very well. All right, increasing for about x has to be less than -2. All right, so let's check that. So from x to -2 is right here. All right, I'm going to erase some of these now. Hopefully, you guys, if you're not quite sure, you can go back and watch it. But just for my sake, so I don't have 900 colors and different things. So now we're increasing. So from -infinity all the way up to -2. If you look left to right, it's going up. So I would say that's increasing. And between 1 and 3, So from here, that's going down, so therefore no. This is incorrect. That is not correct. Because since it's increasing, it would have had to go from here and go up of some sort. Go up of some sort, not down. It went down, so therefore that is incorrect. Incorrect. Alright. Decreasing, so for between about -2. So -2's right there. And 1. That's right there. So I would agree with that. That is definitely decreasing. All right, but we also have to check for when x is greater than 3. So 1, 2, 3. Well, 3, it's increasing. It's going up forever and ever and ever. So that's not possible, right? It's not an arrow pointing down. 3, so that is incorrect. That is incorrect. Okay. Go light blue, baby blue. All right, intercepts, -3, that's right there. 0, 0, that's right there. And 2. So yes, that is correct. Yes, that one is correct. Relative minimum. So let's go to a relative minimum. This looks like a relative minimum. So let's check that point. You always start counting from the origin. So we went 1 to the right. So that'd be 1. And you went 1, 2. 2 down. So yes, this is correct. 1, -2 is a relative minimum right here. Right there. Alright, relative maximum. They say there's 2 of them. Let's check it. Let's check that. So we get -2, 1, 2, up 1, 2, 3, 4. Okay, so it's right there. I would say that's a relative maximum in this little area right here. That's the highest possible point, so that one's good. Let's try 3, 2. So 1, 2, 3, 1, 2. That's not even on our graph. That point's not even on our graph, so no, this one is not correct. And then we have the last thing as, oh gosh, sorry. I don't even know how that happened. Okay. The last thing we have is end behavior. End behavior. End behavior. So as x increases and decreases, the value of y decreases. What that would look like is the arrows both pointing down. But this one's pointing down and this one's pointing up. Therefore, this is incorrect. The arrows need to be facing both down. They both need to be facing down for that to be true. So they needed arrows going down for that end behavior to be true. Okay. On to example 3. On to example 3. On to example 3. So the number of people in line for roller coasters throughout the day can be modeled by a function. Use the key features to sketch the graph of a function, then interpret the key features. Alright, so it's positive, between -0.5, -0.5, so we'll just say it's right there, and 12, which we'll say is right there. It's increasing for x is less than 1.4. Oh, sorry, it's negative. So from down here to here, it's negative. And so basically, it's going like this, and it's going like this. Something like that. Alright. Now the intercepts, they're already given to us. But the y-intercept right here is at 220. So it's 220. So we go from here, this x-intercept, up to 220. I'm going to try and redraw that so it's not so crazy. So 0.5 is probably more here. Going to go up to 220. That's right around there. Okay. And the relative minimum is at 5.3. And that's at 133. So somewhere in this ballpark. Oh my goodness. It's very hard to graph on here. I'm going to zoom it in so I can maybe make it a little easier on myself to draw it. So we get 5.3 up to 133, and that's somewhere. Oh, no, it's a little too high. So 5.3, it's somewhere in that ballpark. Okay, our relative maximums are at 1.4, 1.4, and 448. So somewhere in there, and 9.9 and 643. So somewhere up there. So what it looks like is it's going something like this. That's what our graph is looking like. Something along those lines. Alright, so our key features to know are our x-intercepts, our relative mins and maxes, okay, and then the points at which we are increasing and decreasing. When we're positive and negative, that's crucial to know. Okay. Alright, so again, so right here was 0.5. We got that from here. And our intercepts, 12 is right there. We got that from our intercepts. Our y-axis was 0,220. That's how we got this point right here. Relative minimum, 5.3, 133. So you go to 5.3. It's roughly right around here, 5.5, 5.3. And it's somewhere in this area. It's kind of a rough sketch because the numbers are so large. All right. Relative maximums are 1.4 all the way up to about 448. So that's right around here. And then we went to 9.9, so almost 10, all the way up to 643. So we almost do like 2 mountains almost. 2 hills. We got the first hill, second hill. All right. All right. The check. All right, try the check. Try the check. So part A, which graph would be used to show the height of a dolphin above the water, y as a function of time since it emerges from the water? So the relative max is at 4 seconds. 4 seconds. So there's only one that has a relative maximum. There's only one that has a relative maximum. So the answer is A. Because of the relative max at 4 seconds. That's a min. Sorry. That's a min. This doesn't have a min or a max. That's the only one with a maximum. So that was pretty easy. Okay. Okay, so for example 4, pair properties of functions. Tennis, Hawkeye is a computer system used in tennis to track the path of the ball. It is used as an officiating aid to locate the landing spot of a tennis ball. When players challenge a call, use description and graph of players' forehand, backhand shots to compare the paths of the 2 shots. So now we're actually comparing the forehand, so the little paragraph right here, to the backhand in the graph. Okay, so during the forehand, the ball leaves the player's racket at a height of 2.8. So that 2.8 is the y-intercept. That's the initial height at which the ball is hit. It's the initial height at which the ball is hit. So that's 2.8. Now, if you look at the backhand, this point right here is roughly 2.5. So that's initially where the backhand starts. So that's how we got the y-intercept forehand, 2.8. Let's try to color code this. So 2.8 feet is a y-intercept, And we'll go right here. It's 2.5. Okay. X-intercepts. X-intercepts. Alright. X-intercept. Travels 29 feet. So, sorry. The rocket at a height of 2.8 feet and travels 29 feet. When it reaches a height of about 10 feet, then the height of the ball decreases until it hits the ground at 58 feet from where it was hit. So that's going to be our X-intercept. Whenever it hits the ground, that's going to be our X-intercept. So right here is our X-intercept. It's right on that 70 mark. So that's how we got that. Extrema. Yellow. We'll do yellow. Maximum height of 10 feet because it says it reaches a height of 10 feet. And it traveled 29 feet. Whereas this one, it travels a distance of 35, so right in here. And it went up to 7. So that's how we got these two. Okay. That's how we got these two. And then increasing and decreasing. Increase to a height of 10 because from 2.8 to 10 you have to go up in height. The ball went up in height. And then it reached a height of 10 feet. Then the height of the ball decreases. So when something decreases, it means it's coming down. The height decreases. So that's how we got all of that. Okay, and then we see that increased here, and then decreased down. Alright, so that's comparing. Alright, let's try the check. 2011, China's urban population exceeded the rural population for the first time in the country's history. Use the description of the graph. To compare the urban and rural population to China from 2005 to 2014, where Y is population in millions and X is years since 2005. So which statement about the rural and urban populations of China are true? Select all that apply. Alright, so there were fewer people living in the urban area of China in 2005. So, urban area. Since 2005, that would be 570 million people. 570 million people. Whereas here, about 745 million people were living in the rural area. So there were fewer people living in urban areas. I would say that is. There were fewer people living in urban areas of China in 2005. Okay. The rural population of China has been increasing while the urban population has been decreasing. Okay. As the number of years since 2005 increases, the rural population of China decreases while the urban population increases. I would agree with C. Because if we look here, if you see, so the rural population is the paragraph. And it started at 745 million. Now it's down to 618 million. That's a massive drop in the rural area. Whereas if you look at the urban, it's steadily increasing. Now it's almost up to, well, it is past 750 million people in the urban population. Okay. So, D, the rural and urban populations of China are positive for years after 2005 and negative for years before 2005. I cannot agree with that. I cannot agree with that. Okay. Both the rural and urban populations of China have been steadily decreasing. Well, we can see that's not true. Based on the graph, the urban population is going up. It's increasing. It's going up. So it's definitely not decreasing. Both the rural and urban populations can be multidimensional functions. I would say yes, because it's steadily decreasing, and the urban population is steadily increasing. Yes, I would say yes. Alright. Now going back to A. There were fewer people living in urban areas of China in 2005. In 2005, there was 575 million people living here. Whereas in the rural, there were about 700. So I would agree with that statement. Okay. And the rural population of China has been increasing, while the urban, that's false. So A, C, and I. All right, again, look at Schoology for all the work that is due that you need to be doing in class. All right, so you can watch these videos at home, do them work in class. Right? Have a great day. Remember, so if you're watching this, I know this was a super long video and I apologize for that. But study guide. Don't forget to do the study guide. All right, have a great night. Bye.